Thank you for joining us for session SPS318. My name is Rahul Singla, and I'm thrilled to be here with my colleagues Joe and Jason to share an exciting story about innovation at the intersection of operational excellence and generative AI. I'm a senior enterprise support manager supporting global financial services customers. And today we are going to share a story about how Fidelity took a foundational operational challenge, managing enterprise scale volume of AWS health events and support case data, and transformed it into strategic operational advantage. And then we'll share our thinking in applying GenAI to evolve such a solution to the next step. So let me first start by setting the context for why this matters. Organizations face a fundamental challenge of growing complexities, and your enterprise environment has large volumes of accounts, resources, and events. And in this environment, reactive monitoring simply doesn't cut it. You can't wait for something to break and then scramble to fix it. You need proactive actions, the ability to identify potential issues before they impact customers, to understand patterns across your entire infrastructure, and to take preventive measures. Study shows organizations that have comprehensive data monitoring detect incidents 3.5 times faster than those without. And that's not a marginal improvement, that's transformative. In financial services industries, every minute of downtime can mean millions of dollars in lost revenue and damage customer trust. And here's the key insight that drives everything we are going to talk about today. Different data domains, when combined together, build a holistic picture. AWS health events tell you service issues and scheduled maintenance. Support cases reveals recurring problems and their resolutions. And when you bring them together, you can correlate a spike in support cases with a health event, or connect a configuration change to performance degradation. That's when you achieve the true operational intelligence, and that's what we mean by holistical technical hygiene. All right, let me quickly walk you through our agenda for today's session, which follows Fidelity's journey chronologically and builds on from foundation to innovation. First, we will explore AWS health and support data. Second, we'll dive deep into Fidelity's cloud event notification transport service, also called as SENS. This is the data pipeline and notification platform that Fidelity built to ingest, enrich, route, and act on AWS health and support data at scale. Third, this is where it gets really exciting. We have published GenAI patterns that we can apply on top of systems such as SENS. Finally, we'll wrap up with conclusion and key takeaways. So we'll go into the AWS health and support data. So AWS health, let's talk about the foundational data source that powers everything. AWS health is your window into the operational status of AWS services and how they affect your specific resources. It provides three main categories of information, and understanding these categories is crucial. First is operational issues. These are service disruptions or degradations that are actively affecting your AWS resources. Second are schedule changes. As you are all aware, AWS is constantly improving its infrastructure, which means planned maintenance, hardware refreshes, and service updates. And AWS Health gives you advance notice of these changes so you can plan accordingly. Third is account notifications. And these are very important account-specific alerts that don't fit into any other category. And things like billing alert, security findings, or service limit warnings. And they are very specific and tailored to your AWS accounts, configuration, and usage patterns. Then is AWS support. As you all may be aware, AWS support provides technical support and guidance for AWS customers with specific AWS domain expertise. And the data generated by support cases can lead to invaluable insights and delivers measurable business value while providing organizations with actionable insights from their support interaction to drive continuous improvement. Let's talk about some of the goals here, which are clear, progressive, that build upon each other. Goal number 1 is ingesting AWS health events. In the enterprise, we could be dealing with thousands of AWS accounts, and each of these AWS accounts generates its own stream of health events. Then the goal number 2 is ingest AWS support cases data. And support cases contains incredibly valuable information. They document problems, solutions, workarounds, and lessons learned. But the data is mostly unstructured, conversation between yourself and the support engineering. Goal number 4 is at scale ingestion and routing. And now we are moving beyond collecting data to actually doing something intelligent with it. Different events needs to go to the respective stakeholders. Goal number 4 is data-driven operations. And this is the ultimate objective, transforming from reactive firefighting to proactive, intelligent operations. It means using the data you're collecting to identifying patterns, predict issues, automate response, and continuously improve. And the data is what drives this. As I just mentioned, AWS health data, support data, and we have a lot of data across health and support. And basically lots and lots of data. You can literally drown in all of this data. How can we properly ingest this data at an enterprise scale? Well, please allow me to introduce you to Jason Casimiro, who solved this problem at Fidelity Investment. Thank you. All right, Jason.
Thank you, Rahul. Hello, everyone. So my name is Jason Casimiro. I work at Fidelity Investments, and I'm a vice president of cloud engineering. So a little bit about myself. I work within a group within the enterprise technology group that is really focused on cloud enablement and standardization practices. So as you go to the cloud and scale, obviously you want things to be consistent, secure. The only way to do that is to really have a group focused on how those workloads are managed, deployed, observed. And my group sort of sits in that space. I lead a team of talented engineers who are really focused on a single problem today, when we're going to talk about it. The challenge that everyone has. As you go to the cloud, you lose control. So when you go out to the cloud and you increase your surface area for failure, there's a lot more things that happen. And as people get a taste of the cloud, they start to grow, because it's easy, right? So you expose that to your engineers, and they start to go at an accelerated pace. And what happens after that? You start to get data. As Rahul said, you get a ton of data. So a little bit of Fidelity, a background. So back when Fidelity started in 1946, we were a simple humble financial institution, managing one fund. What happened after that? We were lucky enough that our founders were tech junkies at the end of the day, right? When it boils down to it, they were fascinated with technology and how could it improve their business, because that was the key focus. How could we get our business to differentiate itself leveraging technology? Back when hardware was introduced, computers, those came in. That was a factor. More importantly, we had our first mutual fund website, right? We were one of the first to do that. When the internet happened, we saw that as a potential opportunity to differentiate our business and how technology would help our customers have a great experience. The same thing applied when we came to cloud. When we saw cloud and we saw how innovative, the accelerated pace of delivery, Fidelity jumped in. So back in 2016, we deployed our first app to the cloud. And then, there we go. And then we kept going. So in 2019, we decided really to accelerate our sort of cloud journey. And we started to move to other clouds, right? So not a single cloud, but multiple. So that introduced a number of challenges. As Rahul described again, more data. You increase your data ingestion, more clouds, another cloud, different types of data, things that we have to think about. Today, we look at about probably it's north of 8,500 apps at this point across our entire portfolio, across many clouds, right? So not just one. So flashback to 2019, we were still young. We still hadn't really figured things out. Modest part of our portfolio in the cloud, 12%, about 500 plus accounts in AWS, about 200,000 resources. So still a significant amount, but nowhere near where we were going to be and how we were going to mature. But there were still challenges we had to think about. Again, with every resource you deploy, there are things that happen. There are services it depends on. There are all sorts of things that go out into the cloud that we didn't have frameworks in place previously to understand. And we had to sort of think about it quickly. Luckily, we had a partner in AWS. AWS was a great partner, and AWS Health specifically was a service that we relied on. So at an organizational level, in our organizational account structure, we had lots of accounts admitting things. And so what we really tried to focus on was a consistent way that we could get things out. And really AWS Health supplied that back in 2019. So clearly it's not the robust AWS Health capabilities that you know today, but ultimately it provided a good sound foundation for us to build upon. And we knew, just like the cloud, they were innovating and accelerating pace of delivery at an exponential level that we couldn't think about keeping up with. So it was a great partner to have in our back pocket. The AWS Health API specifically allowed us to programmatically sort of interface with accounts and extract data that we needed, and really think about how we might process that data in a different way and push those out to our stakeholders. So our first go at it, back in 2019, keep it simple, right? There's a lot of system architects probably out there that are thinking, when you get to scale, that's when simplicity matters, because any complex sort of architecture at scale is brittle. It'll break down, and anyone who tells you otherwise has never run anything at scale. So we were simple in the initial sort of go. Simple, reach into an account, pull mechanism on a time-based basis. We go out there, we get our events that we care about, we get our support cases, we aggregate them back into a central hub, and we process them. Simple, clean, just get it out there. And again, we were really focused on rapid delivery, because we are a company that focuses on get things into the hands of the developers as fast as we can and then iterate. We don't want to sort of analysis paralysis ourselves out there, and so this is where we came. So we started to ingest, and then we sent simple things, email, right? You get an email. And I don't know about everyone else, but I get lots of emails. So this got old fast, real fast. But we persevered, right? So we kept going as we start to grow. So we're getting a little bit better, a little bit bigger. We're 9 years in the cloud now. We got about 80% of our apps in the cloud, almost 2,000 accounts, almost 5 million resources, over almost 150,000 events aggregated in the last 2 years, just from AWS. Again, these are AWS numbers, but we are a multi-cloud implementation. So we aggregate across multiple clouds, and then we have an extension that we're potentially going to go on-prem with too, right? So we're trying to aggregate consistent data into a place. So again, you'll hear a lot about AI and agents and all the things that you're going to sort of change the world with here in re:Invent, but ultimately it starts with a foundation of data. If you can't get that consistent and clean, none of these fancy tools that we have out here are going to do anything for you. And so we thought, how do we sort of think about this now? We have a scale problem. We didn't have a scale problem back in 2019. Now we have a scale problem. Luckily, our partner had come along with us. So AWS Health had matured as well. And we knew that was happening, and that was great. One of the key things that they introduced was a few pieces. For us specifically, was a delegated administrative account. So a single account that essentially at an organizational level can aggregate all your events. That was a huge win for us, just because when you start thinking about 2,000 accounts and sort of seeding things into every one of those accounts, it gets dicey fast. Having a single place where all of those things are easily aggregated, that was a huge win. The other piece was Event Bridge, the native integration to services inside of AWS. I can't speak enough to how easy and seamless these things are, but ultimately everyone knows that's here. Event Bridge was a huge win for us. When you start thinking about the integrations as well, right? So they started to think about how do we get these to events and things of note to places that people care about. That's where all these third-party innovations came in. And I think that's a huge win for as well. So whether you do them natively or you do them inside of your own custom delivery mechanism based on your ecosystem, that's a huge win on how you integrate and sort of deliver events. So we had to rethink sort of what we did. Based on some of the ways that sort of AWS Health evolved, that allowed us to rethink sort of our processing logic. Rather than that antiquated pull mechanism, wake up cron-based type stuff, right? Everyone had that cron tab that they lose focus and lose all over the place and all the servers they sort of place them on. We started thinking about an event-driven system. One, based on the amount of resources we had out there and the real time that we wanted our users to react and understand what was happening, it made a lot more sense. The integration with EventBridge was a huge piece. So a single EventBridge role, AWS.health in your organizational delegated administrative account, aggregates 2,000 accounts worth of events, right? And then it's just a hose of information that you have to process. So for us, we introduce it to essentially an enrichment stage. So we look at it and say, hey, this raw event is great, but a lot of our Fidelity engineers need more. So we need context. So how do we sort of pull more metadata, dependencies, upstream, downstream, anything we can get so that they can get a little bit more action and understanding associated to the event that they just got, right? We want to get past that noisy email that just ends up in that folder called trash on the other side that nobody pays attention to, oh, I know exactly what I have to do, or my team knows exactly what they have to do. And that was a huge win in the enrichment stage. Then we started to think about notification, right? Again, back to the email part. We want to meet people where they are. So that's a huge piece of today's society, right? Your phone is on you all the time. You want to understand your user community wants their stuff the way they want it. So really sort of having a personalized preference on how I get engaged. That was a huge piece of our puzzle. Because ultimately anyone can send 10,000 emails a month. It's really, do they get any action? Do they get any traction on the things that we care about? Because ultimately that's the most important part of it. So we thought, okay, how do we re-architect our system? Part of it is we go from an event-based architecture, from our pull-based architecture to this event-based architecture. So we start up in the corner, right? So right here is the core system. So in a single account, my single rule can now aggregate all 2,000 events, all 2,000 accounts worth of events. So we made a conscious choice to sort of send it out to an API. And the reason behind that is, again, back to what we talked about. We're a multi-cloud implementation. To have a consistent pattern on how our events come into our system, we wanted to make sure that everyone who came in and produced events sort of came in through the API. It also helped in our resiliency architecture, right? It was a quick and easy way to sort of pivot over in the event that the system that people rely on is available during the outages that they want to know about, right? So those are the key pieces in our resiliency puzzle and why we made a conscious choice to use Route 53 at the top to be able to route our events in places. Once we go from there, we come down, right, into event enrichment for health. And I'll specifically talk about the left side in a minute. So for health, what we do is essentially the event enrichment starts. So we talk about all those things that we pull off, metadata, upstream, downstream dependencies. We send it off to our cache and our events table. It's just a Dynamo big table, really. That was a key core construct in ours. Our previous one had a little bit more RDS relational stuff. This one was straight big table, easy stuff. The other piece of this puzzle, because of the native integration, was the ability to inject all of this information into an OpenSearch cluster. So from start to finish, it's near real time to get an event into our system, process it, and get it into an OpenSearch cluster that's available for our users to sort of search and look back on events, look back on things in their systems that they care about. We were sick and tired of just, did something happen and people had to answer the questions versus go to OpenSearch and fish. Teach your users how to fish, because that's the only way you get out of this constant cycle of answering a phone. So that was a huge win for us, and an additional capability to introduce in this system that natively was just easy to extend into. Then we get into the notification system, right? So again, we talked about notification. Notification is a big piece of our system because we need to engage our users. It's not just about storing data. We need to make sure we provoke them and say, hey, something's happening, or you need to think about something. Back to the initialization and integration. So we have some key core integrations that we talk about. So everyone's going to have their own internal systems on how you manage work, incident management, communicate from a communication platform perspective. You're going to basically always have those internal tools. We were able to integrate with ours. Again, along with our default mechanism of delivery, which is our email stuff. That's a huge piece of our puzzle. When you talk about the support case side of the house, not as easy. So that's probably a challenge that a lot of you might also be tackling. AWS Health provided a single EventBridge rule that was very easily integrated. Support case, not as much. Luckily, as I had referred to, we work in a central sort of cloud group, And as a part of that cloud group's capabilities, we have a thing called the platform injection framework. Part of that platform injection framework is our focus on how we manage consistently our accounts allows us to do this at scale much more effectively. So with a single rule and a single cross-account role in a package, our platform team now has the ability to deploy and manage that across the 1,900 accounts for us. So I take advantage of an internal capability that makes my life 100 times easier, right? So I can deploy that to the fleet essentially, and now I start to aggregate all my support case data as well, alongside my health data. So as Rahul said, like, this is the stuff that's important on how I sort of bring that data together in a single platform so that we can now start to think about the next generation of processing. When you look at sort of our resiliency, like I said, there's a lot of things that are being released, obviously at reInvent. The AWS Health just did this, I think last week or the week before, but ultimately now we have backups for local regional sort of events as well. So they had global backups as well, but now local regional events are also being backed up to an alternate region. So now based on this framework, again, everything should always evolve and increment, nothing is set in stone. We'll start to increment towards that model as well. So localization, essentially backup for all of our events, so that in the event that US East 1 is having an issue, we can then start to go back, right? And figure out what alternate region do we need to deliver this from. So another piece of that puzzle that we talked about was our people data. So event data is great, we can aggregate it, but as I said, really the power in the system is the engagement with our users. And really we had that initial engagement with email, but like everyone else said, and everyone knows, email stinks, right? That's a terrible way of engagement. We had to come up with a better way. And the only way to understand how to meet our people where they wanted to be met was with a system that sort of captured their preferences. So we have a simple system that we sort of offer up to the enterprise that allow people to go in and basically talk about or log essentially their preferences on how they want to get communicated to. So their medium, their types, what things they care about, and what sort of delivery channels we want to get them to this stuff on. So things like when you talk about, I have a production account, that's what I care about. When things happen there, I want a Teams message or I want a Slack channel message, whatever your tool of choice is. That's a different environment and a different sort of experience than I want for maybe a dev environment that has a deprecated runtime that I need to think about and schedule sort of a change. That's an email, or maybe a work item in my backlog sort of integration. So those are the types of things that we started to think about, because ultimately this whole system is only valuable with action, right? So I got to be able to action into the specific things and make sure that I get my users to the place that they need to get to with the context and information in the right time, right? So that's the key value of the system. We went from a time-based pull system to now essentially an event-driven system that gets this in real time out to the users with actions that they care about. And providing the context is the most powerful part. So some of the wins, right? So things like costs, obviously, financial firm, that's a big one for us. You go from a pull-based model that wakes up, executes a ton of step functions, to essentially a single event-driven system. We're reducing our cost by probably 57%. And then we're introducing more capabilities as well, right? So I already mentioned our Sense platform, search platform, which is essentially our open search cluster. That's a huge win for us. So we added a number of new capabilities and drove costs down at the same time. That was a big win. The other thing to talk about was stakeholder engagement. So when we initially started, we would fire off, 20,000 emails a month, 30,000 emails a month, whatever the number was, with limited traction, right? I had no idea what things were getting done, which weren't. So unfortunately, we still have a lot of email, but we are narrowing it down now more to specifically targeted spaces, right? So whether they're incidents that are raised, service requests that are raised, work log items that are logged, so that there's more action and tangible outcomes that we're expecting from our engagements versus just essentially off in the wild emails. So that's a huge win for us too. As we start to increment forward, that's the things we'll talk about where we go. So we talked about goals. Originally, we talked about a lot of ways that we ingest health, support cases, but really the ingestion at scale. And I can't stress enough, nobody understands a scale problem until you have a scale problem, but ultimately the scaling routing piece and understanding how to manage that in an effective and consistent way at an enterprise level was a huge win for us as well. So we talked a lot about that. But again, a lot of this is foundational work. And so where do we want to go? we talk about data-driven operations. So obviously the whole conference, there's a lot of AI agent stuff, a lot of AI. We've built a foundational platform. So when we look at the maturity levels, AWS does a good job of the maturity framework. We're now getting into a point where we're going to have action-oriented stuff, right? So we are sort of understanding and scaling, but really we want to get to the next. So we want to look at identifying trends, right? So there's a capability inside of our world now that we can look at all of the data items that we get and how do we sort of correlate events, because that's the power, right? When you think about Fidelity at scale, 2,000 accounts, I don't know, something like 15,000 technologists. At any given moment, someone on one corner of the globe specifically might be working an issue that already someone on the other side has already solved because they are understanding their elements sort of that are coming in a lot faster. That happened a lot when we were early on in the cloud, right? Calling another business unit and saying, hey, did you see what happened? Yeah, I already knew that. And not really having that connection and the connective tissue that a lot of these data platforms provide. So that was a huge move forward and as we go. So you think about specific events, right? So guidance and sort of deprecating events. When you look at sort of things like last year was a good example where we had an RDS cert expiration across our environment. And that had to drop dead August 22nd. It's ingrained in my head, right? Because we sent a number of notices and because we were consistent at sort of getting that notice out into the right hands for the right action to happen, we were able to sort of avoid any customer impact with any RDS cert renewal issues. That was a huge win for us, and that can only get better as we start to leverage in intelligence and sort of automation as we start to remediate these events. And then we start to get into aggregating understanding, augmenting operations. Augmenting operations is a big one, right? That's our next level of maturity. As we look at sort of augmenting operations and automating our resolutions, we have this capability in foundational data that now we need to sort of move into the next level of maturity. So how do we get there? So luckily, again, we have partners. So Joe's going to come and talk about applying GenAI with Amazon Bedrock. Thank you, Joe. Oh, he's going.
All right. Thank you, Jason. So you saw what Jason has built in Fidelity upon the data that Rahul mentioned. And you saw those future goals. And perhaps you have a similar system. How do we get there? Well, GenAI. So we released recently in AWS samples, so that there is the GitHub link, a framework that we call Machine Augmented Key Insights, or MAKI for short. At a high level, it takes AWS support data and AWS health data, the two data domains that we've been discussing, into Bedrock. For support cases, we take every single support case and we augment it with reference data, case categories, for example. And then we send that augmented prompt into Bedrock. Those of you that are familiar with prompt engineering will recognize this as a standard prompt engineering practice. And in fact, we're literally just taking the data augmentation into the system prompt and calling the Converse API in Bedrock. And by doing this, we can achieve results like this. So this is a result of thousands of support cases passed through that pattern. And we're able to achieve this kind of identification of different categorical buckets. So this simple operation gives us that next step in Jason's goal. We're able to identify similar event trends. And also, as we're passing data through Bedrock, we do it in stages. In the middle, you see the event level analysis. And then at the end, we see the aggregate level analysis. And notice we're using two different models for each of the stages. For the event level analysis, we use something like Amazon Nova Micro, or perhaps Anthropic Claude Haiku, something very lightweight and fast. And for the aggregate analysis, we use something like Anthropic Claude Sonnet or Opus, a more sophisticated, richer model. I think you're all familiar with the principle that you're here. Use the right tool for the right job. That applies to any infrastructure, including GenAI infrastructure. And also, as more and more GenAI applications hit production, you have to think about resilience, right? Absolutely. So within the framework, we demonstrate some GenAI application patterns towards resilience. And this is one such pattern. So what's happening here is as events are coming in, If we have relatively few number of events, we send it to Amazon Bedrock on-demand inference. And if we have a lot of events, we send it to batch. So let's walk through an actual example. So suppose you have a service event, kind of like the one we had in October. In that case, you'll probably have some support cases as well as health events coming into your system. Obviously, those you want to analyze right away. And since it's streaming in, there aren't that many of them. So that you can send to on-demand inference. But a different use case. It's December, right? So many of you are doing end-of-the-year analysis, kind of retrospect kind of work. Suppose you want to analyze all of your support cases and health events in the past year. A large organization, you may have tens of thousands of support cases. Now, you could feed that to on-demand, but if you do that, chances are, and I'm sure some of you have already seen this, you'll probably exhaust your token counts, and you may get throttled. But if you're doing an annual analysis, you don't need that report right away. So you can send it to batch. And Amazon Bedrock Batch Inference, it allows for no stress on your throttling, and also it's far more cost-effective. So that sort of pattern gives something like this. What we do in that architecture we just showed you, we take every single support case and we summarize it. So the conversation that you have with your support case agent, as Rahul mentioned, a lot of it that contains golden nuggets in how to resolve different things. So we summarize it into an essay, and we also point towards a specific suggestion and documentation as to addressing the support case. And we do the same thing with health. We summarize the health event, give you a suggestion how to address the health event, and documentation as well. So now this gives us that next level in what Jason was talking about, giving you guidance to specific events. And now the aggregate level. So this is that second phase where we're looking at data in aggregate. We have health and support in one worldview. And I think Rahul mentioned they're correlated data. Quite often, when you have a health event, you have support cases as well. So we looked at them in an aggregate, and we asked Bedrock to give us an aggregate summary, a holistic view of our operational environment. And since we had that aggregate view, we can also ask for a plan. In this case, I've asked it for to give me a plan to improve the resilience of my operational platform. And this is based on our prescriptive guidance of AWS resilience infrastructure. So that gives us the next level, an aggregate understanding of our operational environment. Now, this is pretty cool and all, but I think, some of you guys are saying, Joe, this is kind of cool, but this is just document generation, summarization rack, stuff that you've seen before at last year's reInvent. I think by now, we're kind of not wowed by this kind of technology anymore. But that said, it is very effective. But you're also saying, well, this is the year of the agents. And you're absolutely correct. For the next two levels, we do need to absolutely use agents. So let's see how this plays. So back to our Mach-year architecture. And there's another workflow that we demonstrate within the GitHub link I showed you before. So now, as events comes in, we feed it into OpenSearch. And we create embeddings using Amazon Bedrock Titan embedding model. And you see there, we have a bunch of tools for both support cases and health events. We have lexical search tools, semantic search tools, as well as hybrid search tools. And those tools are made available to the MCP stack on the right. It's hosted in Kiro. In this case, using Claude Sonnet. Let's dive a little bit deeper with that, how that OpenSearch index looks like. So this is, I think some of you will recognize, an actual AWS health event. Actually, this is just a screenshot from my OpenSearch UI, like literally. And you can see how I keep the AWS health event, the metadata in structured form, but I also have an embedding as well. So let me make a bit of a point here, actually. I'm going a little bit off the script, but I mean, standing here, I think you can probably tell that I'm rather passionate about GenAI. That said, the pre-GenAI tech, that's still pretty good. I mean, if you have structured data, there's no need to create an embedding for it. A structured query is still pretty good. So the metadata, I keep it structured. That said, I have the event description, right? That's natural language. So that field, I do create the embedding for. And that's that array in the bottom. So now this record can be queried by a lexical search, semantic search, and hybrid search, if your platform allows for it. In our case, we're using OpenSearch, which does allow for that powerful hybrid search capability. So this is kind of cool, but I think we engineers, we tend to build shiny things, and GenAI is very shiny. But if my shiny thing doesn't address a business problem, what have I solved? So let's look back to some of the questions that Jason and Rahul were asking. So I've been in technology for a couple of decades now. And this time of the year, December, this is the question that's always in my mind. Because things tend to expire on December 31st. And I don't want to come back in January with stuff broken, right? Well, actually, but I have all those health events in my OpenSearch index, right? And I have that nice MCP stack on top of it. So this is actually, it's a little green, because I like to see it in green. But this is literally the Kiro CLI, that MCP stack that I showed you before. And I asked, do I have any AWS health events coming up? And now I'm actually able to query it. And now it's, let's see, it's finding a whole bunch. Looks like S3 related events with respect to replication and lifecycle events. Okay. Well, good thing I asked. Okay, that's good to know. Oh, it's happened in January as well. All right. So what has this done? So this has given me awareness of like what is happening. And now that I'm aware of what's happening, I need to take actions. And as we have discussed, support cases are often actions based on health events. And we see that we have health events and support cases in one worldview. So now I ask, do I have any relevant support cases? Meaning, do I have already some actions already in place? Well, so now I'm back to my Kiro CLI, and I ask that exact same question. And now the agent is contextually aware of the health event. So notice, I know it's going a little bit fast, but it's pulling support cases that's only relevant to that S3 health event. And it looks like actually I do have some support cases in place, meaning some of my actions are already in place. All right, this is good news. I already have some actions in place. But you know, I have my favorite S3 bucket, you see. In fact, over here, get down at the bottom, I'm asking about S3 Maki-report.riv. By the way, riv is Amazon talk for reInvent, okay? That bucket is literally what's behind that pie chart that you saw before. And I want that pie chart to function after January as well. So I asked, is that bucket impacted by health events? And let's see what Kiro does now. Notice it's calling S3 API, and it's calling specifically bucket replication configurations, as well as lifecycle event configurations. It's contextually aware of the health event that's happening, so asking for those specific rules. Fortunately, my bucket, it doesn't have any replication or lifecycle rules. It already found from the S3 API call, so I don't have to worry. All right, so I can probably enjoy the rest of this reInvent and come back in January all happy. Not really, because I'm a technologist. And as a technology person, there's always something in the back of my mind. And that is security, 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 absolutely. In this case, critical vulnerabilities. Because I'm sure, how can we forget this guy? Or this guy here? So at this point, I can see I'm inducing PTSD in the audience just by showing this, and I'm sorry about that. But you know, I share that PTSD with you. Oh my God, these guys were painful. Now, in enterprise workflows, I'm sure you already have some CVE checks in your CI/CD flow. But you know what I personally always worry about? What about that CVE that just came out like yesterday, right? Is my workflow accounting for that? I don't know. Well, so now I launch my Kiro CLI in the context of my development environment. As you can see, this is my VS Code. And you see that it's a little bit hard to see, but in the middle, which is get underscore CVEs, that's a simple MCP agent I wrote, which simply pulls the CVEs from the public record. Hello? Oh, there we go. OK, thank you. Now I ask, do I have any CVEs in my that I should be aware of? And in the public that just recently came out. And it looks like it pulled a bunch of WordPress CVEs. Well, if any of you guys are running WordPress, I'm sorry to say, you have some work cut out for you. Fortunately, my framework doesn't use any WordPress, but it's also talking about some command injection and networking vulnerabilities. OK, that sounds serious, all right? And actually, Keter already did the analysis and gave me some recommended actions that I can actually now take and apply to my code. But I'm thinking, this agent is already contextually aware of my entire repo. And you know what the vulnerabilities are. So go find in my code where these CVEs are actually impacting. And it finds them. By the way, in interest of time, I kind of like sped this search up. But that search went through every single line of code. It even went through the libraries in my Python environment. And once again, it gave me recommendations, action I can take upon my environment. But I'm thinking, OK, you know what the CVEs are. You gave me recommendations. You know where in the code that I need to fix this. So why don't you go fix it? And it does. So think about the time when you had to address the heartbleed and the log4js and other issues. Think about how much effort that took. Now I'm addressing this in minutes. So, you know, the bad actors out there, they're already using GenAI. We have to use it too. So all of this I described so far is in that GitHub repo. I'll point it towards the end as well. But now let's really think beyond some of what's already been published. As you can see, based upon the foundations of the health and support data, if we add more and more data domains into our worldview becomes more enriched, and our actions become more meaningful. What are the data can we add here? I think the obvious one is observability, right? So think about those health events that are coming in. Can we correlate them with production observability records? I think it'd be very meaningful if we do. I'm not saying it'll be easy, but I think agentic flows allows that capability. What about change management? I scan for CVEs in my code, right? What about the incoming changes? I would like to scan for those as well. What about cost? Those health events, it has to do with S3 bucket replication and lifecycle rules, right? Does that mean my bucket cost will change? I don't know. Well, I would like that question answered. The more and more data we add to our worldview, the richer it becomes. Now, let's really push the envelope here, OK? Here you are at AWS reInvent. It's just Monday, and you're going to have a wonderful time. Can we add the signals from other providers? Many of you guys are multi-cloud. Once again, not going to say this is easy. And I think this is sort of the holy grail of IT, right? The single pane of glass. I think MCP, to me, in some ways, is like an API aggregator. I think it is possible. And why stop here, right? Many of you have vested infrastructure on-prem. You still have data and value coming in. Add it to the same worldview, the single pane of glass. And why stop here? You saw me pull the public CV data, right? There's many other invaluable data in the public, such as news, or social media, or weather, or financial market data. So imagine a scenario where there is a potential black swan event happening. You see that in the same worldview, and you're able to preemptively scale your infrastructure. How cool would that be? Now, at this point, I kind of run out of space on my little visualization, but I think you get the point, right? continue to add more and more data. And I think that your world become more and more enriched, and you're able to take better and better actions. So, to conclude, right? The AWS health and the AWS support data that Rahul mentioned, start there. This is your foundations, okay? Upon those foundational data, build something like what Jason did at Fidelity, an enterprise scale framework that ingests the volumes of data and also further enrich with your own proprietary data, make it yours, and then send it to the respective stakeholders so that the actions can be taken. That by itself will give you much value in that 23% slide that Jason has showed you. And once you achieve this, to get to the next levels, you can now apply GenAI. And in particular, using the GenAI framework, continue to add other data domains within your worldview on top of the health and support data. You know, it's just Monday, and we've already seen some announcements, and I'm actually very excited to see the rest of the announcements. But personally, I'm also really excited when we'll meet again next time this year. Because I believe, honestly, that many of you will take patterns like this and build amazing products. And I think our world will change by next time this year. Okay. Please join us at the support booth to see what else we're doing. I believe there's also a workshop they're conducting on Kiro. I believe SPS318 is the number. So you can actually try it, hands-on try out what I was just showing you. And well, that again is once again the GitHub link to that Maki repo if you missed it before. And myself, Jason and Rahul, we thank you very much. Thank you.